such as 5 raised to the third power. The base in this expression is the number 5, and then the power is the exponent. So the power would be 3. So just identifying the pieces. If you're given an expression and asked to write it in exponential form, this is very, very basic, you would write a base of x one time, and you would cube it since there are 3 multiplied by them, by itself 3 times. Write a base of y once, the power becomes the square. Write the base of z once, and the power becomes 4. So writing in exponential form is taking an expression such as this and turning it into something like that. And now let's do a few of the problems together. Let's look at number 6 together. In number 6, I have a negative times a negative, so my product answer will be positive. The sign will be positive. The only coefficient number is 2. And then you write the base of x one time, and you add the powers. So 3 plus 2 is 5. Write the base of y one time, and then 4 plus 5 is 9. So just going back to a basic application of the power. Let's look at a problem like number 18. So in number 18, you're using the problem, or you're using the property from number 6, but now you're in an expression where you're creating like terms. So I have 7 times 2 is 14, a base of y once, and 4 plus 2 is 6. Move to the next expression and do the exact same thing. 2 times 7 is 14, a base of y one time, and 3 plus 3 is 6. Once you've created the like terms, you just simply combine their coefficients. It just so happens in this problem that the coefficients are additive inverses, so you have 0 y to the 6th, or simply 0. Everything just canceled out, so this equals 0. If the problem would have turned out a little bit different, let's say we've had 14y to the 6th minus 10y to the 6th. Here you have like terms, the same variables raised to the same powers. You simply combine their coefficients. 14 minus 10 is 4. The variable and the power on the variable remain unchanged. Let's look at number 35 together. Number 35, I have an odd power with a negative sign inside parentheses. You could think of this as a negative 1 raised to an odd power. So you know your final answer will have a negative sign in front of it. And then I have a coefficient of 3. I'm raising that to the 5th power. 3 to the 5th is not 15. 3 to the 5th is 3 times itself 5 times. So that's 243. And then finally I have x squared raised to the 5th. So I have x squared raised to the 5th. We have a shortcut for dealing with that. Whenever you have a power raised to another power around a set of parentheses, you can simply multiply the two exponents for x to the 10th. This expression is really telling you that you've got x squared times itself 5 times. Turning it back into one of the first properties that we've learned, and you would write the base one time, and then you would add 2 plus 2 plus 2 plus 2 plus 2 5 times for a sum of 10. But when you have the exponent around parentheses raised to another exponent, a power to another power, simply use the shortcut and make it a power of 10. If you need to write it out, though, go ahead and do that. Do what you need to do at this point to get the correct answer. But this is a shortcut version of the summation property. I want to make one change on the back. Let's look at number 15. If I multiply this out, I would get n squared plus 3n plus 2n plus 6, combining like terms, n squared plus 5n plus 6. A vocabulary piece here, identifying the constant in a product like this. The constant is the number without the coefficient, so the constant in this product would be 6. The number without a variable, rather. So the number without a variable is the constant. So in number 15, when I multiply the binomials to get the product, 6 would be considered the constant. I want to change this and combine. I'm going to do number 16, but I'm going to change the y to an n and create a different problem. When I multiply these together, I would get n squared plus 3n plus negative 6n plus negative 18. Combining like terms, that gives me n squared plus negative 3n plus negative 18. If I had a problem like number 15 and I set this expression equal to an expression like the expression given in number 16, so we've already distributed this out and figured out that it's n squared plus 5n plus 6. If the problem looked like this, simply multiply each side. And then the squared terms will subtract out and sum to 0. So the squared terms have summed to 0, so they're gone. And I have 5n plus 6 equals negative 3n plus negative 18. And you simply solve this for n just like you would have done at the beginning of the school year. And n is negative 3. You should be able to do an area of the shaded region. We've practiced that in class, so you should be able to do that. You should be able to name a polynomial based on the number of terms it has. So here, this is a trinomial. I have 1, 2, 3 distinct terms. Another trinomial, 1, 2, 3 distinct terms. If you have a single term, it's a monomial. 2 terms that are not like terms, it's a binomial. And 3 terms that are not like terms, it's a trinomial.